what in the industry sees, even if I hire a person or if any person hires a person
In chemical industry.
in chemical industry, if a person has done BTech, he's mostly still likely figuring himself out and coming to job.
Okay, there's always this mindset
Yes.
for hiring managers.
Hiring managers, that a person who has done BTech is still figuring himself out. He may work here for 1 to 2 years. So there's a high probability that he will go either in a well-paying job or go to do an MBA. But a person who has done a master's, he has a belief that out of all the options, he chose master's in chemical engineering and he has excelled in. So we see the CGPA, we see the projects what he done.
And then there's no option if you think that you don't like this subject in masters, right?
Correct. So if he has demonstrated his caliber in the masters, he has got a good CG, he has got a good projects, and he has, because masters, the project is the main thing. So he's done that good. So that means he has interest. And that means this person will stick around more because he will try to do masters from US or any other company just for any other country just for moving there is highly not recommended.
Okay. Why so?
Because the jobs are of chemical or of any core industry are limited there, and it's very difficult for a master's person in chemical to land a job.
Hi, Rohan Bhaiya. I mostly consider you as Bhaiya again because since long time I have been considering you as self.
Correct.
So welcome to the CC channel. I mean, I'm so grateful that you have come here, and too much thankful.
Thanks for giving me this opportunity. I never thought on a Saturday morning I will be doing a podcast, but here I am, and thanks for giving this opportunity to me.
Great. So, talking about your experience, I mean, starting from your 12th standard, I mean, then you shifted to Bachelors in Chemical Engineering, right? So, how have been your journey? Why you have chosen Chemical Engineering at the first, site?
So, I distinctly remember then when I was in 12th, I literally had no idea what about I was going to do. I just had a dream that I have to go to IIT or BITS. That 2 colleges I had kept in mind. After 12th, I didn't get a good rank in the competitive exam. So I dropped 1 year and retook the JEE exam and BITS exam. So after that, I got around 5,000 rank in JEE and some 315 score in BITS. So at that time, the old IITs were there and the new IITs were not that much there. So getting into the old IITs was my dream. Otherwise, the next best option was BITS. So I took the chance that I had 2 options, either get a chemical engineering in BITS Pilani or CS in BITS Goa.
Okay.
So I didn't know because Goa that time was new.
Yes.
So we already heard a lot about Pilani. So that's why I went Pilani. Whatever branch I was getting in Pilani, I was that was the honest story that I didn't choose chemical. Chemical chose me there.
Okay.
So that was there.
But for me, it actually happened the reverse way. I actually wanted to go into chemical engineering because I thought probably there are a lot of chemical concepts involved in that, and I was weak in physics and somewhat in mathematics as well. So I thought probably if I go into chemical engineering, there are a lot of chemistry involved, not physics.
Yes.
But I think that's a misconception.
Yes. So the biggest misconception about chemical engineering is related to chemistry.
No.
But that is not.
No.
Chemical engineering is purely and purely physics.
Yeah.
It's the application of chemistry on a large scale, and how that chemistry translates is how to do physics.
Physics, exactly.
So all the concepts are about physics. So if you are, if you have an inclination towards physics, or if you have slight this at how do chemical processes work, and how do they do at large scale. So for that, chemical engineering is a very good subject. So people in IIT and a lot of people who have good command on physics, they will choose usually engineering physics. There's a different engineering physics.
I think BITS Pilani also offers dual program or something wherein they can choose both.
Yes. So BITS Pilani has a very good thing that either they will give the normal engineering courses, and they have another thing called MSc program. So they have 5 MScs: MSc Bio, MSc Eco, MSc Maths, MSc Chemistry, MSc Physics. And with this 5, after the second year, based on your CGPA and some calculations, you can take any of the engineering subjects. So in 5 years, you will be doing MSc plus BTech in that engineering.
Oh, great.
So that so the best combination, usually people will do will be MSc Maths plus BTech Computer Science or Triple E, MSc Physics plus Mechanical or Chemical. So they will be doing that.
Okay.
And MSc Bio, usually they will not go in engineering, they will take Pharma, B Pharma or B.
Correct. Or some biotech as well, right? Biotech engineering
Yes,
also
yes.
there.
So that's a very good combination, so that you'll know the theory part, the full research part, and then the engineering, the application part.
But I think it has been around, 15 plus years since they have been offering these courses. But still, we are not seeing it in mainstream. Right? Only I think BITS Pilani is still offering these courses. Other colleges may not be offering such courses, I think.
So the chemical engineering was part of the original core streams from long back. So chemical engineering, mechanical, civil, and electrical, and so obviously was there. So these things were there from long back. So IIT Delhi, IIT Mumbai, all old IITs were offering this chemical engineering from long back, because I think chemical engineering was coined in late 1800s.
Oh, is it?
So a person, I think diverged the mechanical into two parts for specifically focusing on chemical processes.
Okay.
So it was so after in 1900s, chemical engineering was very relevant, and especially with the boom of oil industrial revolution, which led to the boom in oil and gas industry. So they wanted mechanical engineers which are dedicated to this chemical industry.
Chemical industry.
So that's why this stream diverged.
Correct.
And so that's why this chemical engineering was a very old branch, not as old as compared to mechanical, but it's quite old. And it was one of the core branches from the starting onwards.
Okay. Of course, yeah. Right now the booming courses are computer science, which has come in a modern times.
Yes.
I think with the medieval times or something as such, wherein the oil prices and oil were coming into picture. So then itself the chemical engineers has seen a surge in the jobs and everything. Exactly. So talking about, you have talked about mechanical engineers versus chemical engineers, wherein we have chemical engineers immersed from mechanical, upskill themselves into chemical processes and everything. So what do you think in the current situation, in the industries, what roles are mechanical engineers playing and what roles are chemical engineering playing? Because chemical engineers also are playing in terms of chemical process as well, but also they are taking care of some of the mechanical components, wherein we have seen that in our subject itself there are mechanical operations subjects involved and few subjects which is correlated with both of the streams.
So basically what we understand from chemical engineering is that mechanical and chemical are closely related. If you see the courses also, heat transfer and thermodynamics is common for both.
Yes.
And the books are also common.
Yes.
But however, when you go to the industry, so if it's mechanical, mostly works on how the machine is working. Okay. So in a you cannot have any chemical plant without any mechanical operations. So any machines.
Yeah.
So what happens that any machines are working. So the theory of machines, the hydraulics, the background behind those machines, which are how do you say that they are how they are working, how to troubleshoot those machines. Those are still mechanical engineers, which they come under reliability and maintenance engineers. So every chemical plant is split into two. So one will be the production and the chemical engineers, and one will be the mechanical engineers, because all the reactors, all the utilities, everything are handled by mechanical engineers. But the process part, so where the core chemical lies in this, that because if you see a pure mechanical industry like automotive, so there is what? So there is just mechanical parts moving. So there are only mechanical engineers required. But in a chemical industry, you have a reactor in which there is a reaction. So for upkeeping the reactor and hoping that the reactor works fine, that is a job of
the maintenance part,
mechanical engineers. But finding out whether that reaction is going and how much impurity is going to form, how much of our desired product is going to form, that is the duty of the chemical engineer.
Correct.
So there's where the difference is. So this is not coming to pharma. This can be equivalent to any fertilizer company, any FMCG company, where any healthcare company, any chemical you have, from your Harpic to your Tide to your tablet. So everywhere, and to your petrol.
Okay.
Everywhere the chemical engineer is engineering has to be used.
Even paints as well, I think.
Yes. So you think of any chemical which has impacted you on a day-to-day basis. That chemical has been produced by a process that was developed by a chemical engineer.
Chemical engineering.
So it's basically starts by a chemist. A chemist does it at lab scale. The chemical engineer takes it from a lab scale to a
They
manufacturing scale.
upscale it mostly.
Yes.
And talking about, one more sort of engineers which play a very pivotal role, instrumentation engineers, right?
Yes.
So that is a part of a mechanical engineering again.
So instrumentation is both part of mechanical and chemical as well. We have a course called process controls, in which we have to learn about PNID controllers and all that transfer functions which are called. So that is part of instrumentation. But nowadays, if you see, because now everyone is seeing industry 4.0, 4.0. So that is the industry 4.0 means the automation and digital industry. So here comes that the very importance of instrumentation engineers, because all the things which we were doing earlier manually. So suppose I have to note the process is going. Suppose there is a distillation going. So I have to go write readings of vapor column pressure, reflux rate and everything. And I have to maintain it and see the quality of fractions. So now everything is getting automated.
Correct.
So if a person has to go forward, if a industry has to move forward, it has to adapt to these changes.
Yes.
So automation reduces the probability of manual errors.
Yes.
So that is one thing, and it gives more robustness of the process. So that is what you have to do. So ideally, what a fully automated plant would look like, that the automation is automatically checking the quality in process. Suppose I'm giving a example of petroleum industry. So you have a distillation column in which
Continuous process, right?
continuous process in which you will get 7-8 fractions, top from LNG, then liquefied liquefied nitrous gas, then you will get the naphtha cut, then you'll get the kerosene cut, then you'll get the ATF cut, then you'll get the diesels, then in bottom you'll get
The wax and everything, no?
wax and the tar and everything which is used. So you have to maintain the distillation column such that the quality of those cuts are maintained. It should not have like I am getting petrol cut in kerosene cut.
Okay.
Because the composition of chemicals which are used in petrol are different in kerosene,
Yes.
and different in ATF, aviation fuel,
Yes.
and it's different in diesel.
Yes.
So you know what happens if you put diesel in a petrol car or petrol.
Yes. Yes.
So that's why those cuts are important. So if you can have an automation that in which the cut you are testing that quality of the cut, and with you have given a feedback that whenever that quality of cut is about to go bad, so if suppose instead of C6, C7 compounds, you are starting to get C8, C9 compounds. So then your process should modify itself in such a way that it rectifies itself. You increase the reflux rate, you increase the reboiler rate, so that it rectifies it such a way that the cuts come properly. Okay. So this is the future of industry. So this is just given an example. It's the same in pharma where I work. So it's similar in that you have to have such kind of PAT tools, which are called process analysis tools, which give feedback to the process whether you are going correct or not. So one important concept which is this automation is bringing is batch versus continuous.
Okay.
So earlier, all processes usually in chemical were batch processes, that you give one lot, make that one lot. Suppose you make one for fertilizer, make that one lot for fertilizer, and then send it.
I mean, charge, discharge, then charge too.
Yeah. So that. But now the thing is, now the world is moving towards continuous manufacturing, because the continuous is more easy to control and more efficient as well. So you don't have to, because there are batch to batch changeover times, batch to batch down times.
Exactly.
So those are eliminated.
Cleaning,
Cleaning, correct.
Yep. So you have talked about industry 4.0, right? So what about the earlier versions, and like what can we expect in industry 5.0? Because anyway, there's seeing a lot of automation happening in 4.0 itself. So what is your take on this? Like what has been, what is going to come?
So earlier, the basic chemical engineering, which was any industry which started, one is in pre-industrial revolution, one is post-industrial revolution.
Okay.
So before industrial revolution, everything was usually manual labor. So with the advent of steam engine, which got the industrial revolution started, you thought that you can make energy do the work. You produce energy, and that produces rotational motion, and then that can produce work. And those works can automate your things. So that's why this industry went through a lot of phases. So industry went from the starting basic, that you have to have a rotating, you are taking a steam engine and you are just rotating yourself in a workshop or a lathe machine, and that is working. So then came with that your locomotives also, steam locomotives and everything. So then started ki you can use electricity. So electricity, you can use it. So electrical motors and this, and what do you say, this steam engine. And after that, the starting of basic assembly lines and robotics, minor basic robotics, that if a person has to weave something, weave a textile, so automatic, there are weaving machines that can automatically do. You set it, they will take this is like a sewing machine. So how did sewing machine? So sewing machine was a part of advancement. Earlier people used to sew with hand. So sewing machine was the next step. So similarly, all the machines, starting from, if you had to make any tablets at starting, you had to do it all manually. So now it was slightly automated in the 1950s, 1960s, and it is more automated in 2000. And it will be what the Japanese say, that only one person per shift will be required to manufacture the whole.
I was coming to this point itself. That because I have seen over the years, the manpower, the human resources also required, that has come in a decreasing manner. I mean, starting from the pre-industrial revolution to now. I mean, even now we can see if a batch requires maybe 10 personnel, and now it will require only 3 to 4 of them. So do you think, in, like, as you said, only one person will be required only for the monitoring purpose? How many years we can see that while? And then how can chemical engineers, do you think there will be job cut in the chemical engineering field then?
So actually, it's a very tricky question about that, and no one can say what will happen in the future. But it all boils down to the economics. So currently, if you want to manufacture paracetamol, that is suppose hardly 2 rupees, 3 rupees per tablet. So if you put an automated line there, so the current economics don't cater to that. If you put a fully automated line and put, instead of humans, robots or any fully automated, which takes that and does everything, you will definitely at this point of time will have 1,000 rupees per tablet. So the economics of automation is still not that much viable right now. If you pull a fully automated line, like nothing is there. However, there is a thing that in future, as everything says, that the cost of chips and the microchips and this, everything will come down. So at a certain point of time, maybe in 2050, 2060, it may be equivalent or economically feasible to manufacture such. However, I'm still thinking the second question you asked, the job cuts. So it's not about, it's the question that everyone is saying, will AI takes this jobs, will automation take this job? So it's not that. It's about what role you were doing as a chemical engineer pre-automation. So that role has to be upskilled. So that is the only thing. So if you were doing a routine manual labor of only doing some things which can be, that doesn't require any thought or thing. You just have to do something which is given set of instructions and you have to execute it. So yes, so that may be impacted. However, if you are in a thing where you have to take decisions of whether how to control this pressure, how to control this temperature, how to do this, so that will still not be controlled.
Or the complete design of the process.
So that part is very important and critical, because the chemical engineer, from the engineering principles you learn from experience cannot be replaced by automation. So especially it comes in safety also, because automation, you will have some certain interlock, certain controls. But if you see that a certain reaction is not going the right way and it is going off wire, or it is going towards a safety incident, so you will know with a chemical engineer experience that yes, this can lead to a safety incident, and then you will stop that process. So these kind of experience from engineering will never be replaced. Only one thing that I always say to everyone, that certain problems which were a mechanical one will translate to a instrumentation or IT one. So with automation, this is the problem. So earlier you would have majority of moving parts, and those parts used to cause the problem. But once you automate everything, the problems will usually come in those sensors and the feedback, because there is so much automation that the reliability of those sensors and this will determine the process and its robustness. Because if currently what happens if I'm making a reaction, if a reactor stops moving, so the motor, the gearbox is a problem. So then my reaction won't go. However, in the future, it will 99% more probably not be because of the reactor stopping moving.
Okay.
Some sensor is not giving feedback to our system, which is not giving the feedback of putting the agitator start, will be mostly the problem.
That might be a blunder, because it will be again a continuous process, a lot of batches coming into picture here and there. Yep. I think, but again, there are a lot of improvements to go into that place. Definitely. So what do you think, like, the chemical engineers right now have to skill themselves in for the near future? Do you, like, again, I think a project management is one such thing that they should be looking forward to, because a lot of projects are coming into picture, a lot of automation happening.
Yes.
So what are
I believe that chemical engineers who are freshers, they have to first decide what is their path. That is a very difficult question, but see, as of now, I tell this to everyone, that chemical engineers have basically 3 to 4 paths of.
Okay.
So one is a path of after fresher, if you go, that is into directly go as a graduate engineering trainee, GET, into any chemical company.
Yes.
So the salary is low, but the exposure is high. You will be working at the down level of producing. It could be in a chemical plant, it could be in a fertilizer plant, it could be in a petroleum plant. So this is the first thing that is. Second is, if you are slightly interested in research, so then you can go in the research side, go do a master's, go do a PhD, and go into slight research side. You can go into teaching also and parallelly do research. So second is that. And third is the chemical engineers who can do a techno management role.
Okay.
So that is, do work in the industry for some time, take MBA, and then go the business side of chemical. So you will know the chemical engineering and the basics, and then go to the MBA side and develop your business to generate more revenue.
Correct.
So these are the 3 things that are in between. In these also, there are a lot of ways, but these are the broad specs. So if a chemical engineer, as per me, so if you are going into a GET, so obviously your salary will be very less compared to your peers with this, because that is a very common thing, that you get paid according to how much contribution you give to the company.
And and also want to add how much value you are creating.
Correct.
How much value. In case of IT, I think they are outsourcing, of course, that are coming in dollars, but in terms of pharmaceutical, wherein they are always looking forward to compete in the market and put the slash the prices further, I think that makes sense.
So there's a thing is that if a client in IT, especially in IT and this, a person can, with this basic training. So the thing was that any IT engineer or a computer science student can be productive, can do client projects, because if a client projects that I want this software and this, he can directly start contributing company and complete that project for the client. It may be some hundreds and thousands of dollars. But however, a chemical engineer, the real worth of chemical engineer comes after 10 to 15 years experience. Because you cannot give an operation of a chemical engineer. Suppose you are making a pharma. I'm giving example because I am from pharma. That you are giving engineer the whole process to handle. So suppose a process. So one batch usually in pharma is somewhere around 3 to 4 CR. One batch, if you consider all cost, 3 to 4 CR. So can a person who is a fresher, even with 1 year training, can be given that full process for one, which is one batch for 3 to 4 CR?
No, not at all.
So one thing is, what about safety? What about quality? What about any incident which has happened? So this is where in chemical engineering the experience is still comes more. So if any person, if he dies taking that tablet, if he has a side effect,
and there won't be only one, there will be plenty of them.
Plenty of them, yes. So So there was a very good example which happened. I won't name the company, but we got to know that there is a thing called the painkiller.
Okay.
So painkiller,
Yeah.
in that painkiller, I think ibuprofen. So there was a old story. This is 1990s or
Okay.
2000.
Okay.
So what was said that in 1990s, ibuprofen, there was this, and they were manufacturing in pharma. So what happened? Ki usually we have quality controls and everything. So at one time, usually every time the batch comes around 200 to 210 kg. So one time it came 195 kg.
Okay.
So the people got confused. Ki why? So there the non-chemical engineers of that time, they told, okay, we'll proceed. That's 5 kg less. What was we? But the chemical engineers don't know. We have to investigate. So why this yield has come less? So it may be due to some other reason. No. Every time we manufacture this batch, it's coming in 200, 210. Maybe some manual losses or something might be there. But the chemical engineer asked why it has never come before. Why this time only have come? Maybe the normal people came. Why? Maybe some reasons or that. Then okay, can we release the batch to the market or something? They told. So bolda ki no. So we should not do that. So finally they found they found it. They then the chemical engineers all told ki we have to find the reason why the yield came low. So they found it, and they found that there was a raw material.
Okay.
Raw material was white.
Okay.
So it comes in bags of 10, 20 kg. So during dispensing from the warehouse, the one person had mistakenly put a raw material bag and replaced it with a diabetes medicine bag.
Oh my God.
Okay. So if suppose that batch would have been sent, so that had one bag, 20 kg of that 200 or 210 kg
Yes.
was with a very potent diabetic medicine. So if a person does not have diabetes and he would have taken that painkiller, his sugar would have been down and he would have been died if suppose that batch had been released. So that is why these kind of things, these kind of things which come from experience are very difficult. And these will come when you are in the industry for 5 to 10 years. Then only you can find these problems in this. So that is why people, if a person writes a code, it will, if you test it, the tester will finally find this is the fault and this is But at this stage, if you give a 3-4 years experience person the whole plant and this happens and several people get killed, then that cannot be, that risk cannot be taken.
I mean, there will be a lot of consequences. The regulatory consequences. I mean, the bad reputation and everything.
Your site head will go to jail and the company will be given a ban for 6 months.
Oh my God. Then it really makes sense. I mean, 10 to 15 years is a must. At least that much. And what I think is, when you talk about the IT engineers, they actually code and they can demonstrate how much good skill set they do have. When it was chemical engineers, only here experience matters. Where again they can analyze on basis of experience how much knowledge do you have in that field, right?
Yes.
There might be here and there of other things, but I think these all things what you are talking about, the consequences of it can only be, rejected or can be like stopped when you have good experience, when you know about all the components of the chemical industry altogether.
So that is why the people who are at the higher position get the big bucks, because they know, because two things are utmost important in any chemical industry. Okay. So for pharma especially, quality and safety. For other chemical engineers, especially safety. Any other chemical.
Yes.
So because you cannot give a design of a process. You tell a person, if you tell a 2-3 years old experienced person, you design this process, I want to manufacture this plant, and you design this process. So he will not know, mostly he will use this chemical engineering, but he may forget the safety aspect. And if you see every 1 month or 2 months, you will find one factory in Gujarat, some blast has happened, 2 people have killed, one factory in Vizag, blast has killed. So this is where your experience comes as a safety and quality. Because the person who are at the higher, they have to ensure that there is no safety incident or quality incident at site. The process can go up and down. That is not an issue. You can, you have to deliver timelines. That is for business. But before delivering timelines, you have to ensure that no person at the site dies because of his work.
Correct.
So that is where you have that experience. So that is why people who comes as GET, who come as this, they will cry a lot. Why we have to do this shop floor? This is so this, but it is those training. They are getting less salary. They are getting to more hazard. But it is that training which after 10 years, when you are managing a set of people, you will come to know that what can go wrong and what cannot go wrong. Even if it's automated, even if it's not automated, the safety and the quality aspect of it, because the risk is so high, especially in pharma and chemical engineering, the fertilizer industry, because it's crops, the risk is not there. But if a person is consuming vehicle, consuming a tablet, so that risk is very high.
Yes. Okay. So
one thing that I forgot to mention, you were asking me that what about the upskilling?
Yeah.
So that part I had missed. So as I told, if you are in three told, one is the core GET,
the master's one,
and the master PhD, and the MBA one. So these are the current. If you are trying to go in the core industry, non-core is separate. So for the GET person, apart from chemical, you will understand that when you do that. So that is my personal recommendation, that when you analyze a process and this, you will have to work with a lot of data, and your decisions also have to be very data centric. So as I believe that any person who is either going for this core for master's or research, because master's research is also very data centric, and MBA, and this is obviously very data centric, has to have certain kind of background in data analytics or data science.
Yes.
Which will definitely help you, because any decision in future, if you present anything to the manager, has to have a certain, has to be backed by something. Person cannot just take a decision based on experience and convince other people. You can tell that his experience is there, but it has to be backed by data.
Okay.
So that is where maybe it can be anything. Data analytics consists of analyzing the data and presenting, dashboarding the data and everything. So that is very important.
Okay.
So that is one thing that I believe that chemical engineers, apart from their core, obviously they are working day in and day out as chemical engineers. Apart from that, their core, they should have a very good command of data.
Data. I mean, everyone would want a chemical engineer, but some data management or data analytics course as such.
Yes.
I think there was a mistake. Yeah. I mean, if everything is working towards automation, there are a lot of, the data types that were coming into digital itself, where you have to again analyze and see how it works.
So I will give you a first-hand example of our industry only.
Okay.
So earlier, there was no continuous monitoring. So suppose there was, you do a reaction at suppose 30 degrees. So we have a range of 30 to 35 degrees. So initially you will, what the person will do, every 1 hour he will write the temperature.
Write the temperature.
Correct.
Yeah.
So every 1 hour. So if I have manufactured 10 batches, all 10 batches, suppose the reaction time is 10 hours. So every 1 hour I will have a data point. But now with the data logging and the automation, I get the point every 1 minute.
Every 1 minute.
Every 1 minute.
And you can see the outliers.
We can see. So if a person is not good with data, so if I suppose manufacture 50 batches and the 51st batch fails, so what will be the necessary thing? That you have to analyze 50 batches.
Correct.
50 batches has one data point. Easily you can put in an Excel, see physically only that, okay, which is different. But if you have 50 points with each 1 minute, 10 hours, 10 hours means 600 minutes. 600 data points for just one operation multiplied by 60.
Correct.
If you don't have a basic knowledge of data and how to handle large quantities of data, how will you survive in that industry? So these kind of skills have to be developed, otherwise you will be obsolete.
Fair enough. Okay, since we have already bifurcated these three, I mean, talking about GT, then Masters and MBA, I'm coming to the second point about Masters, right? So you have done Masters from IIT. And before that, you have worked in a continuous, the petroleum industry there. So what made you come into Masters, and what is the way to get into IIT, to do Masters from IIT itself?
So basically, like there is a JEE Mains and JEE Advanced for BTech, for after
BTech graduates.
BTech graduates. There is a thing called GATE. So GATE is a graduate aptitude test for engineering. So that is the gate to get into IITs, and it is accepted by all places. So other colleges also, like BITS also, and all other, they will take their GATE score. So what is, you have to think that if in your 4 years, so one I would definitely ask the people to reflect that if suppose after 4 years they don't have a job, so so you are in two places. Suppose I'll simplify it more. You are at two places. One is that you have in a core industry, you have got a job, okay, and one is you haven't got a job after your BTech.
Yes.
So people who have got a job and people who not got a job, they have to ask themselves whether they are interested in chemical engineering or whether that job they are going to do is really what they want to do. So what happens, what I've seen, that if a person has not got job, even they hate the chemical engineering, they didn't like the chemical engineering, they will write, I don't know, I'll write GATE. So that is a very wrong thing to do. If you don't like chemical engineering, don't go write GATE and even worsen your life by doing masters. So a person who has interest in chemical engineering found at least 1 to 2 subjects interesting. It's not like you like the whole chemical engineering, at least 1 to 2 subjects interesting. He is the one person who can think, yes, I think this is interesting, I can do some research on it. And maybe after masters, I may decide whether to go the research way or to take a job at a slightly research oriented job. Because what in the industry sees, even if I hire a person or if any person hires a person
in chemical industry,
if a person has done BTech, he's mostly still likely figuring himself out and coming to job.
Okay, there's always this mindset for hiring managers
that a person who has done BTech is still figuring himself out. He may work here for 1 to 2 years. So there's a high probability that he will go either in a well-paying job or go to do an MBA. But a person who has done a master's, he has a belief that out of all the options, he chose masters in chemical engineering and he has excelled. So we see the CGPA, we see the projects he got.
And then there's no option if you think that you don't like this subject in masters, right?
Correct. So if he has demonstrated his caliber in the masters, he has got a good CG, he has got a good projects, and he has, because masters, the project is the main thing. So he has done that good. So that means he has interest. And that means this person will stick around more because he will try to develop. So
correct.
So that thing is an important point to all the budding chemical engineers, that please don't do masters. CK, you can take CAT because if you are finding you can do something else, but don't do masters just because either you don't have a good job or you don't have interest in it and you are out of job. So that is one thing you should get. If you have interest in 1 to 2 topics, please write GATE. GATE is fairly simple. You can, it's just
for chemical engineers or for all profiles, because I've seen
for all profiles is highly competitive. Because for IT and the talent pool is huge because it's common, because most of the local engineering colleges will not give chemical engineering, but they will definitely have CS, EEE, IT. So that's why the talent pool, I don't know the exact numbers, but the people who write GATE for chemical is hardly around 30 to 40,000 per year.
Okay.
While in the IT it goes around 2 to 3 lakhs.
Oh my God.
So the competition is slightly this, but that does not mean this, but it could be that there are 2 to 3 lakh people, only 50,000 to 60,000 might be serious.
Yes.
So
yes.
In chemical, you will find that till 10,000 people will be serious.
Will be serious enough.
Serious. So that narrows down the competition. But in GATE, if you get a rank in top 200, you will directly get calls from the PSUs. So you directly a job. So that is also, if you want to get into jobs, you will directly get a job into the PSUs, IOCL, BPCL. And from usually people from 150 to 300, 400, they usually get into the old IITs.
Okay. Talking about, masters again, or from abroad. I mean, from Germany, many of the people are choosing to do their masters from those countries, like even US as well. So what do you think? I mean, if someone wants to come to you and ask, like, I want to do my masters, what would you recommend from those countries?
So I have a lot of friends who have done masters, and this is just my personal view.
Okay.
Masters from US or any other company just for any other country just for moving there is highly not recommended.
Okay. Why so?
Because the jobs are of chemical or of any core industry are limited there, and it's very difficult for a master's person in chemical to land a job. there
for a non-resident.
Non-resident. So this why is two things, because there is a very good very good impression of Indians that they are good in coding. So the CS and IT people, as their America or any place is booming, and so you can definitely go there and you can have ample of jobs. But the core industries usually are very, especially US, are very stringent, and some people like some oil and petroleum or some, they will have certain conditions. They will only hire Americans.
Americans, yeah.
So especially if anything is related to defense also. So defense and a lot of industries which are supplying to defense, some chemicals, they will usually have that we will hire Americans only for their country's safety.
Yes, yes.
So that is one thing. And second, masters, which I have a lot of feedbacks from people, that masters from America or masters from this, unless and until you want to go to a PhD, it's not recommended, because masters as such is from any college. I have heard a lot of people from literally Berkeley getting jobs on the last day of their work visa. Okay, so that was the thing. Berkeley also, people were getting jobs on the last day of the work visa, and we have a lot of people who have gone in this University of Pennsylvania also, and in US, in the Europe, Delphi also. They also, they have not taken jobs. They have gone for their PhD.
Correct.
Because it was difficult to find.
Yes, yes. So I would, I'm able to get some. I get an example, live example of one of my friend who actually moved to US for his MS degree again. So he went to a good university. I mean, writing all those GRE, I think he had wrote good marks again. Got to university, started studying chemical engineering, and he landed a job in IT segment itself. He couldn't find a job in chemical engineering, and he had to join because of so much of loan that he has to take.
Correct.
And also there is some sort of limitations of that in that limitation you have to find a job, otherwise you have to return back to your country. So he had joined that, and simultaneously while working there, this recession happened. So you're not very much sure about when can it happen, when the jobs may go down. So now he was stranded for 2 months. I mean, he wasn't sure like how to get, where to get. He was like, I want to get whatever jobs I get, because that company which he joined stopped sponsoring his visa. So then he started looking for all over the world itself where I can find it. He was a good university student in Bangalore itself, and again he got good grades over there as well. But again, yeah, you have to always be certain about uncertainty, right?
Yes, uncertainty. So that's why I suggest that if you have a lot of money with you, or you have back of money, you are not mortgaging your home or anything for going there, then definitely you can go.
Yes.
But if you are only going for Masters of Chemical Engineering just because you have to go to you have to move that country, or you have found that that is not good for especially chemical. For CSIT definitely, but for chemical it's very risky to do.
Yes.
And most of the people, I would say most of the people don't get a job, and the PhD, they have to go for PhD.
PhDs, yes.
So
because there's no other option then.
Yes, no other option. So that is one thing. So I would suggest, and in anywhere, because if you go to Europe also, Europe there's a thing of language, and then with that language you have to, if you are a chemical, if you are in IT, you can definitely do your work will be related to computers basically. But as a chemical engineer, you will be working in factory, so definitely that language skill is more important than IT, because you have to manage people who are working in the chemical plant.
Yes.
So the language is, even if you go to Germany and you say that okay, German is required, you learn little German and go through with your work for IT, because your interaction is minimal with the people. But if you are in a chemical industry, then your 100% interaction has to be in German. So you have to be very fluent in German. So that thing is there, that the thing is, if you want, the bottom line is that the same, that if you have to do masters, then please go with the idea of doing a PhD also.
Okay.
Because beforehand only, if you get a good job after masters in the core, well and good. But don't bank that after masters only I'll get a job and I'll make that exit. Think while you're going from India that after masters you will have to do a PhD. And if you think that, you will have a research-oriented mind. There are a lot of companies which take research people, but it will be difficult. but it could be there. You can get it. So always when you are going for, think with the mind that you are going for masters plus PhD. You have to do it.
Okay, coming down to the industry parts of it, since you have worked in both petroleum as well as pharmaceutical, what are the other industries that can employ chemical engineers?
So chemical engineers, as you told, you look around anywhere in your household, anything
In the water treatment plant as well.
So nowadays this is a thing that chemical engineers who do research in masters and PhD also are going into biology side, because chemical engineering is very diverse. Okay, it's not fixed to
biology side.
So biological side. So what do you say? So if you want, some chemical engineers have become cancer researchers. So it's all about, so body is a marvel of chemical engineering. You see, you have its electrical engineering, which is in the brain. You have the mechanical engineering, which is in the movement of the joints and this. You have chemical engineering because of this pump, heart is pumping the liquid, your kidneys are pumping this. So
refining blood.
So this is a perfect this. So what more, a better thing of a chemical engineer to do is to go into bio. So if a chemical engineer is, if you see a lot of papers in journals of chemical engineer, lot of people are going to bio. They are finding drugs which can cure a lot of things because they understand the dynamics of the body. They can sit alongside the biologists and give them solutions that this, if you give this, this might happen. If you give this.
Now I see what all ways chemical engineers are evolving.
Yes. So
automation part, biological part. I mean, of course, for automation also chemical engineers are required.
Correct. So if you want to, so everything, that any instrumentation person, if you want to automate any process, has to have a domain knowledge.
Correct.
You cannot automate without.
This is the evolution of chemical engineering.
Yes. So if a person, is a chemical engineer, he can go from designing the best sunscreen, which does not give cancer, to designing the best fertilizer, to designing the best agrochemical, which improves the quality of the crop, to designing the cure for cancer, to designing alternative energy sources. So energy is also a part where chemical is huge. You can have renewable energy, wind energy, solar energy. So designing solar cells and this semiconductor. So the person who are involved in manufacturing of all the semiconductor, if you see the semiconductor, they are like even more stringent than pharmaceutical on their area, because even a spot of dust, if you are making that chip, even a spot of dust can ruin that chip. So you have to have a very clean area. So in that also, so chemical engineering is like literally unlimited. So wherever you start working on it, you will find chemical engineers there.
Okay.
So that is right.
So coming to the third point that you said about the MBA part of it, right? Like chemical engineer choose MBA as well. So mostly, what do you say, if they have to go into the core industry again, doing this MBA, how they can contribute having the chemical engineering experience, education plus MBA?
So usually I'm not recommending MBA just out of, because then that's not core chemical engineering, because people who do MBA directly after their college don't do MBA for their core. They are doing MBA to get a job in any of the MBA things, sales, marketing, finance, or this. I'm saying a person who has experienced around 8 to 10 years of experience in chemical industry, and they get an MBA done.
Executive MBA.
So they can definitely work, they can apply their knowledge of this and understand when they go into, after MBA, like you'll go into business development roles, project management roles. So when you have that experience of this and you go in the top, so you know what are the realities of the ground. You cannot have a deadline. You cannot put deadlines like a person who does not have any knowledge of the If you put a deadline, we will make this batch within 2 days. But if you know that when you work that it will not happen in 2 days.
Yes.
So definitely there is a thing of experience which comes after MBA, and the same will be helpful if you are managing bunch of people who are maybe coordinating with this operations. So you can be in supply chain. So you will be closely coordinating with operations. You will give deadlines that I want this material at this time. I'm giving you the key raw materials this time. So I'm giving you this lead time. The production will say, I cannot do it. So if you were already in production, you will know how much lead time they'll take to manufacture. If you are in project management for new molecules or anything, you know what hurdles will come with new molecules. know what hurdles will come if you make a new process. Or
no one can make you a fool.
Yeah, no one.
Because then you know.
Yes, correct. So these are the usually people who are the polished people who go top in anything. So if they are chemical industry, you'll know something about a person is saying, no sir, so this reactor problem happens always. So that is why we cannot manufacture. So you will know that I have worked with the reactor. This problem does not happen.
Doesn't happen.
So why you are making a fool out of me? So these kind of things are definitely important. But with the MBA, you will definitely, right now you will be working on the technical side. There you will be working with the money side also. Because you will be tasked to complete projects which actually give higher revenue to the company, and you will be on the business side. You will be looking at the P&Ls, the profit and loss statement. That if you don't, this will directly impact the P&L. So if you are just on the shop floor and doing, that much impact on P&L might not be there. But if you are there working, so your one decision can impact the P&Ls.
But one more thing, I think that the most, the best specialization that actually correlates with the chemical engineering. Okay, I think one branch that actually very correlates with chemical engineering is operations from MBA. Because I've seen few individuals who have done their operations and then into operations part of chemical industries, right? So, yeah, I think one is that.
So basically, if you work in any operations, you are a chemical engineer also, you'll everywhere see that any operation, is a chemical operation, whether it's a mechanical operation, whether it's any operation, there will be a thing called operational excellence everywhere. So that is where if you do an MBA, it's not required to do an MBA. You can also do that Lean Six Sigma, Black Belt and Green Belt courses. So that is also very important because those operations concepts are applicable everywhere. Whether you are doing a chemical operation or whether you are doing a logistics operation in Amazon. Maybe I'm giving an example of Amazon. A lot of people who are chemical engineers have successfully transitioned their career into Amazon, where they have to find that what is the best way to do an operation which produces the least waste and the maximum efficiency.
Correct.
So that is why every chemical engineer is doing in their field. So this is very common because when you are working in operations for 5 to 6 years, you will definitely know that what are the non-value added works that normally people do, which is the lean concept. What is the value added work, which is the non-value added concept. You are able to easily identify that which thing should not be done, which thing should be done to minimize waste.
Yes.
So, and the part of the green belt and black belt is also some data analysis. So how will you know whether the process is robust, whether the process is not robust, whether and how to analyze data versus good versus bad. Suppose you have a good batch, you have a bad batch, how to analyze what went good, what went bad. So these things are very common across all industries. You work in automotive, you work in logistics, you work in chemical engineering. So these kind of operations, if you have a background in chemical engineering, definitely you can excel in operations if you have worked in that operations side.
Okay, got it. So, now I just want to tap into the roles in your pharmaceutical industry. Just an overview. So, starting from the quality division as well. So, what are roles available in the chemical industries and only the qualification required for that? An overview of the same.
So, basically, especially I'll talk about pharma. But if you want, I can talk about other industries also. But I'll start with pharma. So, any pharma is divided into usually 4 parts. 4 general this. So one will be formulation side.
Okay.
So where you make that final medicine. One is the API side,
which comes to the customers.
Yes. You make the suspension, make the tablet, you make the
packaging and
capsule,
everything.
you make the inhaler or the anything. So those are the formulation side. One is the API side. API side, which means API means the active pharmaceutical ingredient.
Yes.
So in a tablet, there will always be the active pharmaceutical ingredient plus some excipients to make it stable. So the API manufacturers are the active pharmaceutical ingredient. One will be the R&D division, where you will research to find new either generic molecules, how to make new generic molecules or make new molecules. And one will be the business side. So business side includes all business development, supply chain, finance, and regulatory, which is very important. And this is a business department. So basically, if you are a chemical engineer, so usually in API you are the most in demand. So API industry, anywhere in the API industry, any department.
API means active pharmaceutical ingredient, right?
Ingredient,
Which makes powder.
so which
Chemicals
makes
to
the
powders.
active ingredient which acts on your body. So as I told, any medicine will have the active ingredient which the doctor has prescribed you to take to relieve your discomfort or your disease. The other are to keep that thing stable in the chemist shop, in that shop, and it dissolves fastly, so that it gives you that active ingredient in that certain time. So the other things which are called formulations, those are the other things, but the active ingredient which the doctor has prescribed, that is the thing we make.
Okay.
So in API, anything, any industry related to production, sometimes engineering also. Engineering mostly have mechanical engineers, but chemical engineers are also desirable because they can relate. If a certain thing has gone wrong, and projects of engineering also, they can relate that what about the production side, and they can have better cross-functional team involvement. The production side obviously, and the quality assurance side. So if you have chemical engineers in quality assurance, so if you, for people who don't know what quality assurance is, those are the people who ensure that every time our batch is of full quality and
Complying
with all the regulatory guidelines, and also with the safety guidelines for the patient safety. It should not have any impurity which may cause certain side effects to that. It should.
They have their policing authorities.
Yes, they are the thing. Quality control is the testing. So those are mostly chemists, MSc chemistry, MSc. But apart from quality, every place chemical engineer in the API industry is desirable. You can have we have in production, we have the pilot, we have the kilo plant, we have the pilot plant, we have the production scale, we have manufacturing science and technology, we have warehousing persons. Every person, chemical engineer, can work. So API, there is no dearth of any. Actually, we are facing a problem that we are not getting good chemical engineers. So there's a supply and demand that we want good chemical engineers, but we are not getting good chemical engineers.
So, yep, again a follow-up question on this. So you're talking about good chemical engineers. So while you're hiring a fresher in your team from chemical engineering, what are you analyzing him? What are you evaluating him for?
So any interview, which it's a general rule of thumb for anyone. So any interview is just a fact that whether two things, whether what he has written in his resume is actually correct, and secondly, whatever is his expectation, whatever my expectation of this role, will he meet it? So that could be different criteria. So one thing that usually, that is my personal preference, that whenever if it's a fresher, so then I'll ask him about his subjects a little bit. So I'll just basically ask him, I'll not ask any subject. I'll ask him which subject does he like. Because if I asking him random, because we also were chemical engineers, 9, 10 subjects. If you ask anything, you'll not remember, because that some teacher was not good, some time I didn't like that subject. So we usually ask him which subject do you like. So if a person likes the subject, then it is thought that he would know about that. So if a person likes the subject and does not know about that, so then it's a big question mark whether to hire him or not.
Yep, exactly. Because then we are playing according to him. But still in that round, if we're not performing, I mean.
Correct. So that is why. So if I hire him, I make him like the job, and still he will not evaluate. So that's a red flag there.
Yes.
So that is why the first thing is, if there's at least 2 to 3 subjects you should be good in. So any industry. So you no need to do projects of any, like you want to go to some 6 weeks you have worked in some industry or something. That is secondary. But whatever your project, whatever is your first thing, or your subjects, at least 1 or 2 you like, so we can ask 1 or 2 questions. Okay. So whether, this is a simple check, this is why exams are there, that if you have given some work, whether you will be able to analyze and perform on it. So it's just a check of that. So I may not, in our field, I may not give that work to do which is related to subject. But is that if I give you work for 6 weeks or 8 weeks, after 8 weeks, will you be able to perform? The same like you were given a subject to study for 6 to 8 weeks. Do you understand anything? So this is a basic interview that is just a check a person comprehends something which he likes.
I like how you have connected with the academics as well.
Yes.
Why is examination required?
Correct.
And how does it evaluate you?
And second thing, which was this, that you should not exaggerate on your resume, because that is one big red flag, because that is...
And if you're not able to answer about that.
Yes. So the same thing. So if a person writes his resume, half of the resume is regarding one project. Okay. And when I asked someone about that project, he told I only was there for 2 weeks and I did this. Okay. So then I told, within 2 weeks, how can you do all this? So well, no, this was this. So whether you took some material from there or how did you, within 2 weeks, a normal chemical engineer will come to know what are...
Yeah, I think there's a sort of trust issue also.
Yes.
That happens.
So that is a very big red flag, because even if his academics are brilliant in this, if I hire that person, then if I am on leave or if I have to send that person to do a cross-functional meeting with some other department, so then it's a big question mark, because even if he has not known, he can exaggerate and he can give some false statements, and that false statements will immediately bring the trust to our department and to everyone. So that's the one thing you can... Even if a person is not good in academics, I will take him. But if he's found lying on his resume, or lying is a very broad word, even found slightly exaggerating on his resume, because we know what 2 weeks of chemical engineering, you cannot change the whole industry. You cannot find any things that will give you $2 million of worth of revenue or profit. So we know that. So we'll get...
So honesty is the key.
So honesty is the key, because any industry, academics is secondary. Honesty, if you don't have honesty, so then to definitely, because if you know, in pharmaceuticals, there's a big thing called data integrity.
Correct.
So if a person does any data integrity, he will... There is no other rules to fire any person. Only if he does data integrity, if he is found to lie on the document, any regulator will not take that batch of yours. So you are definitely 4 to 5 crores in loss, and that person has to be
laid off.
So these two things, which I feel and which I've seen any other chemical engineering recruiter, that anything which... And this comes same for slightly experienced people also.
Okay. For lateral hiring.
Yeah, for lateral hiring. If you, whatever you have written on resume, so suppose we have interviewed some production operators. So there are some things which a production operator will do day to day. So it's a normal thing. Okay. So every day, a person, I interviewed some person. Every day I check the relative humidity of that area. So I'll definitely ask, what was the limit of that relative humidity? If he gets confused, if he gets flustered, then I know that if a person is doing for the past 3 years one work, and he's just didn't even analyze one thing, that if he's noting some value for every day for the past 3 years, he didn't analyze what is the significance of the value, what is the meaning of the value, what is the limit of that value. So then that person is just
not learning.
Not learning. He's just doing what is told. So then these kind of roles are usually removed by automation. Noting down values, not thinking, just filling documents. So these are the kind of roles that chemical engineers who is about to this has to be very careful. So those are my suggestions to upcoming budding chemical engineers, that please have 1 to 2, whatever your work you have done, please have some good command on that. So a person who cross question, you should be able to hear. And second, your honesty is the key.
Okay, got it. So one last question I do have about reason. This is one of the trending question for chemical engineers. So is chemical engineering a good branch? Why and why not?
So it depends. It's very, it's not a yes or no answer, but I can explain it. So basically, chemical engineering, if you get to know it, if you think it's chemistry, then it's definitely not a good branch for you. Once you get to know it, and if you are interested in physics, it's a very good branch. If you take my story, I didn't know what chemical engineering is, but in the 2nd to 3rd year when the core courses came, I came to love it, because it had everything. It had the fluid dynamics, the differential equations, it had the heat transfer, mass transfer. So I thought it would be related to chemicals and everything, but this was all physics, and I was very interested in physics. In my JEE and bits also, I think my maths and chemistry marks were less than my physics. So once I noticed that my whatever I learned in physics is good, getting used, and whatever the physics thing is getting used, so you will definitely love chemical engineering. But you should come it's a caveat that chemical engineering for a career. So it is very difficult if you are from a tier 2 tier 3 college.
Okay.
So that is one thing. If you like chemical engineering, it's very helpful for being a tier 1 college, because the job opportunities with the pay you are expecting are
Fairly low. Yeah.
So the GETs and this are usually paid very less, because they are usually the company is paying them for being trained. So that in another 5 to 6 years. So that is the reason that people might not feel chemical as a lucrative option. But I assure you that if you are good at anything, anything can be lucrative. So that is there, that chemical engineer, because it's a thing that even I don't get paid. What I say, that chemical engineering is one of the best branches of a person who likes physics. Honestly, if a person is interested in physics, it's one of the best branches of anyone. And the possibilities are innumerable. As I told, you can go from a cancer researcher to a petroleum engineer to a person who designs sunscreen and finds for makeup the perfect SPF for the makeup person, for anything. So it is innumerable. So chemical engineering, if you go into research, especially the people are doing research, and that chemical engineering research is really impacting the world. So that is one of the best things that you can do, and you will not have a single day which you will find boring in your this, if you do that, because it is what you have learned and it is what you are doing. But the same caveat comes that from a tier 2, tier 3 college, you might find challenges finding a good job where you can apply all these principles. Okay? You will mostly start in a lower job, okay, where you might have to do routine work. But over a time, if you are passionate, definitely you can do. And same as, why not a person who does not like chemical engineering and has more interest in other things. Okay? So then for that, engineering is just a way to find himself. Okay? So that is a thing that people usually will come to know within the first, second year, that this, instead of this, I could be very well do coding and learn Python and learn data science and this, and I can get a good job. So people, for that, definitely, if person is interested in coding and this, so it will be there. It's not a good option. But I suppose that because if you see the chemical engineering, people, it's different from where the every crowd, in Hindi we say bhed chal.
Bhed chal, yeah.
Correct. So if a person, if you see, if during a recession, chemical engineers are least impacted usually.
Least impacted, of course.
Because there is less of chemical engineers and there are a lot of chemical processes.
Yes.
So they are mostly people who have some value which is being demanded by the market. And it's that the value is not in abundance, those people.
Yes.
It's I would say that in IT and computer science, even though they are having more and more technologies and the data and the AI is giving more this, but at a certain point before this data, they were literally in abundance. People were in abundance and the jobs were less. So that, but in chemical, you will have people who have who might have experienced a lot, and they will go to higher roles. So therefore, the lower part will have a lot of job opportunities, and those job opportunities only will can be easily grabbed by these upcoming chemical engineers and make way up the corporate ladder. And this is only regarding this. If you are in research is endless.
Yes.
Right now we are at the seminal position in chemical engineering research. If you go to any IIT or any site or college and you just see the research, of what they are doing. There is an IISc Bangalore. There is a thing called I forget, if you see a research, they are researching on a lot of medical devices which chemical engineers required. This is a combination. This is a CFT in which your chemical engineering and your instrumentation engineering and your this, like, it's similar like how to find a diabetes insulin. So people are making insulin pumps which can automatically check your glucose, and based on that value they can pump that insulin, and you don't have to take insulin and check. So it's a continuous system. So these kind of cross-functional things are endless. any chemical engineer wants to do research, go to any college. Go to first take top 25 colleges in chemical engineering. Take IITs, 5 IITs, IISc Bangalore, ICT Bombay, anywhere. Okay, and see the research areas. The tab, see research areas, and you will find such good research areas that you will be amazed. And you say, "Ki, yaar, this area is chemical engineers working. This area is a chemical engineer working." So if you see, then you will know ki what research area. So I was interested in research. I wanted to do my PhD earlier, so that's why I know this. But because of some,
I mean, also, because you're more interested into this chemical engineering background, and also I should say, only the people who are very much interested into this domain, especially, they should come into it and should not fear about the salary, which is part of that. Eventually come with experience.
It will come. So I would suggest any person who likes chemical engineering should definitely take a bite of research. Okay? If you do in masters, if you do in bachelors, that is separate. But if you once you get that this, what do you say, the
Motivations.
motivation. No, once you get the whiff of the research, it will be like you cannot get more of it. Okay? Because there are so many things in research. So research is one thing which actually is me. But okay, even though I am working in a normal production job, but still research.
But you also more of researching, right? I mean, you are finding out.
Yeah, we are finding out. So we are, but mostly we are
not an research, but a sort of research.
It's something between research and production.
Yes.
So we are coordinating with R&D, we are coordinating production to find the right way of troubleshooting problems. So that is there. But if you see, that's why I suggest every chemical engineer, if any inclination to research, just go to all these colleges and see the research areas, and you will be just amazed by what research areas they are doing research, and you can find the true width of chemical engineering there.
Great. Thank you, Rohan, then for all the information that you have done.
Yeah.
So I think it will go on and on, but again, we have to come to a stop.
Conclusion, correct. I can speak there full for 2 days also.
I mean, that makes you when you're interested in a subject altogether.
Yes.
Yep. So thank you for your time again.
Welcome, Vishan, and thanks for having me on the show.
Sure.
Thank you.
Yeah.